Everybody, welcome back to another fun and exciting pre-calculus class. Today we are going to jump into chapter number 7. I've been talking a lot about chapter number 7. I feel like chapter number 7 is kind of like the pinnacle of trigonometry. I mean, it's really as high as you can go. There's some other stuff that we'll be learning about trigonometry, but we build all the way. The first part of this year would build all the way until chapter 7. Chapter 7 is, it's where it's at. So what are we going to do? If you look in your book at page 134, here's what we're going to do. We are going to solve trigonometric equations. What does that mean? Okay, well, what is solving an equation? Solving an equation is getting x by itself and say x equals something. So we're going to have a variable, all right? And we're going to isolate that variable, and we're going to get it to say x equals something. Now, it might not be x, it might be, a trigonometric function or something like that. The sine of theta equals, but the theta is your unknown, the theta is your x. But the concept is the same as any other equation. So let's kind of go through this real quick. Let's just talk about some of these different things and look at their steps that they have, and then we'll just start solving some and see how you do. So the first step that they give you, and these aren't really steps necessarily. It's not like you're going to go 1, 2, 3, 4, okay? These are like guidelines. These are like life hacks right here, pre-calculus hacks, trigonometry hacks. So how are we going to do? What are we going to do? We're going to now be working with both sides of the equation. Remember when we verified? This is not verification. These are two different things, okay? Verifying, you're only working with one side, so you get this equals this. When you were verifying, you didn't really solve. You didn't get an answer, right? You just got that sine of theta equals sine of theta, something like that. You didn't even know what it was. In verification, you're just trying to get the two sides to kind of equal each other. In solving the equation, we're actually working both sides of the equation, trying to get it down to its simplest form, trying to isolate the theta, trying to isolate the variable so that we can get, sine of theta equals, and then a number. Next, substitute from the fundamental identities or forms derived from them. So this is where you kind of go back to page B, which is the front cover of your book. So go ahead and jump back there. So this is what it's talking about. Cofunction identities, product to sum identities, double angle identities, Pythagorean identities, half angle identities, quotient identities, reciprocal identities, sum and difference identities, negative angle identities, sum to product identities. Basically, what they're saying is go back to page B, go back to the front cover. Wear out the front cover of your book. Just keep going back to it. Every single problem, you need to look back into that front cover. These are in different places in the book as well, and the front cover tells you where. So let's say that you're struggling with one, or maybe you're struggling with the double angle identity thing. Well, it tells you go to page 125. That's where you're going to find more information about that. You could also go back to one of the previous videos. This stuff is so difficult to understand that some of you might have understood it kind of to do the homework, do the practice problems, but then now that we're a few weeks away from doing those, you don't remember how to do them anymore. So watch the video again. I know they're long, but take the time to do that if you are struggling. Okay, so let's turn back to the page in our book, 134, and let's look at some more of these. Take a look. Number 3, the third kind of hack that they give you. Perform algebraic operations. Okay, you remember algebra? You can never break algebra rules in trigonometry. That's why we taught you algebra before we taught you trigonometry. Because in order to do trigonometric equations, you need to know how to do algebra. So, factoring, parentheses, basically order of operation, right? Simplifying expressions, doing the same thing to both sides. If you add to one side, you got to add to the other side. All these different things that you did, all the steps that you took in solving equations in algebra are the same steps that you're going to take in solving these equations. Next one. When the product of factors equals 0. Set all the factors equal to 0 and solve individually. So what do you mean by that? So if you get anything that ever zeroes out, you just set everything equal to 0. You create secondary equations. So you take whatever zeroed out and you make that its own equation. Then you take the next one and make that its own equation. Maybe you'll have 3 pieces, 4 pieces. Who knows how many pieces you'll have? Typically 2. But you may have more. And if they zero out, then set everything, all the factors equal to 0. Same thing that we did when we factored. Remember, we would set it equal to 0, x, so you'd get x plus 3, x minus 3, and you'd have to set both of them equal to 0 in order to solve it. Same thing that we're talking about right there. Okay. Next, avoid any process that may introduce variable values. For example, don't use a calculator. You're like, wait, what? Don't use a calculator. Don't get a value for your variables too early. That's like the last thing that you're going to do. In other words, if you do it too early, here's what's going to happen. You're going to be using a calculated value all the way through your equation, and you're going to come up with something that's maybe close to the correct answer, but it's not the correct answer. So don't use your calculator while you're doing these equations. You do it all by hand. Next, do not cancel a variable. So, like, sometimes it's very tempting. Like, look, you're like, ooh, I can cancel. Sine of theta is a denominator here, and sine of theta is a numerator over here. I'm going to cancel. Well, theta is a variable. You can't cancel sine of theta. I mean, you can, but here's the problem. When you do that, you might eliminate part of your solution. You might eliminate your whole solution, so that now you don't get a solution. It comes out really weird. So be careful. Don't cancel variables. The last one says find all solutions from 0 to 360. Or in other words, all of the solutions that are inside of the unit circle. Find them all. Okay? Don't leave it just with finding one solution. Find all of the different solutions. Or then it also says from 0 to 2 pi, which is the same thing, right? 0 to 360 is the same as 0 to 2 pi. One's working in degrees, one's working in radians, but by now, hopefully you know that those are the same thing. Okay? Now what are we going to do? Let's practice. Let's try some of these. Go ahead and turn the page over to page 135. And let's try example number 1. Example number 1 says, solve this. 3 cosine theta equals square root of 2 plus the cosine of theta. Okay, so let's jump over here and let's try to solve that. Now, what we're going to do is we're going to kind of continue to reference back some of those principles. I won't talk about them all, and I won't keep going back to the screen, but I'll just kind of highlight them kind of when they come up and things like that. So what do we want to do first? Well, what you want to do first, I think this is pretty much whenever you're doing any sort of an equation. I always have one that I say. I tell my students, my algebra students, do what you can do. All right, do what you can do. What does that mean? In algebra, you always look at the algebraic sentence, the algebraic equation, if you will, and you try to figure out, what can I do? All right. Are there any like terms? Is there anything that I can distribute? Is there, what can I do here? And as I look at this one, there's not really anything I can do. I don't know what that is because that's a variable. I don't want to figure that out. Why? Because it's an irrational number. So we don't want to, again, we don't want to use our calculator anywhere. And I don't know what the cosine of theta is. So I can't really do anything yet. Now you might think, well, I could I could combine some like terms, because look, I have a like term over here and I have a like term over here. You're correct. Okay. That's what I would do first. I would start moving my, another thing that I always say is move your letters to one side and move your numbers to the other side, right? Well, in this case, this is the theta. This is the unknown. That's the variable. That's the letter. So this is also a letter. Why? Because it is a variable, cosine of theta. and it matches with this one, also cosine of theta. So I would just subtract the cosine of theta from both. Now remember, that is a 1 cosine of theta, right? There's always a 1 in front of it. So when we subtract over here, we're going to subtract 1 cosine of theta. That will cancel on this side, and we'll be left with 2 cosine of theta equals the square root of 2. Now, again, kind of just going back to basic algebra, you should know here that I'm trying to get this by itself. This is not good enough right here. So I just need to divide both sides by 2, and I come up with the cosine of theta equals the square root of 2 over 2. Now, something should be kind of like popping into your mind right now, like, hey, I think I know that. And you're correct. You do know this, or you should know this. If you don't know this, then I have done a poor job of teaching you, or you've done a poor job of learning what you're supposed to learn. So what should be popping into your mind right now is the unit circle. And so what you want to do is remember, okay, first of all, and let me take just a second to show you this, because I think that sometimes we might kind of forget this. What are we looking at? Let's take let's take this one, for example. What is this first one right here? All right, so the first one is a 30-degree angle is the square root of 3 over 2. Well, what is this point? Okay, this is the x point. What is this point? That is the r point, or that's the hypotenuse, right? So what is that? That's x over r. All right, what is x over r? X over r is my cosine. All right, and this one is my y, and this one is my r. So that is my sine. Y over r is sine. How do I figure out what the tangent is? Well, I just take my x, okay, 1, over my y, square root of 3. And so that is my tangent, because I just took these and put them over each other. So made a fraction out of that. So remember how to do that with the unit circle. So hopefully you remember that. So again, let's go back to our work here. And we are looking for the cosine. Remember that your cosine is your x over r. All right, so we're looking for the first one, because we have x over r and y over r. And so we want to find this one, because this is the cosine, because x is the adjacent. So coming back over here, we're looking for, oh, look at this right here. All right, well, that's a 45-degree angle, because look, they're both square root of 2 over 2. So both the sine and the cosine are equal in that one. Why? Because it's a 45. So our angle is going to be 45. All right, now let's come back over here and let's write 45, because this means the cosine of theta equals 45 degrees. Now, before we go too far, I want to show you one other thing, and that is all students take calculus. We always have to come back to this. Where is cosine positive? It's positive in 2 places, remember? It's positive in the first, and it's positive in the fourth. Notice we have a positive because there's no sign here. So not only is 45 an answer, because that one's in the first quadrant, right? We also have another one that is also positive. And remember, one of the things, look over here, one of the things that we said, you have to find all solutions anywhere in the unit circle. So from 0 to 360, we need all of the different answers to be in there. So we need not only the 45 degree, but we also need the one that's in the fourth quadrant. Do you remember how to do that? What you would do is you would say that it equals 45, and you would do 360 minus 45, that it also equals 315 degrees. So 45 and 315 are your 2 answers to that question. The next question that they give you on page 136 is 2 sine of alpha plus the square root of 3 equals 0. So again, kind of just let's break this down. I'm going to go through these first few kind of rapidly because I had to do some explaining and I don't want the video to be too long. And then I'm going to come through and there's 3 more examples that I'll do in a second video. So I'm going to do the first 3 examples in this first one and then the second 3 in the next one. So what would you do with this one? You would just kind of look at it and say, do I need to substitute? What can I do? And one thing that I see that I can do is I want to get this by itself, right? That's my goal. That's where I'm going. So I can take this square root of 3 to the other side and notice that I'm going to have a negative over there on that side. So now I have 2 sine of alpha equals negative square root of 3. I'm going to divide this side by 2, divide this side by 2, and that's going to give me really kind of my solution that the sine of alpha equals negative square root of 3 over 2. Now, this is where we kind of get into this. Notice I have a negative answer. So where is sine negative? Let's come back over here. All students take calculus. And let's talk about where is sine negative. Well, sine is negative in the third and the fourth. So our answers need to be third and fourth. And I don't care how you do this. Some students do it like this. You know, they'll write third, you know, and then kind of write an answer, and then fourth and write an answer. That's fine. If that helps you to separate it in your mind, what you need to do. So what we would do here is we got to go to our unit circle and find out. Now, you can use your calculator here. You really can. But you should have it memorized for the most part. You should kind of know where we're going with this, or you can just use the unit circle. So let's pop over here to the unit circle, and we are looking for negative square root of 3 over 2. Really, to be honest, we're just looking for the square root of 3 over 2. Why don't we need that negative? Well, we could use the negative and look on the unit circle, or we could just do it finding the reference angle, and then we could do our subtraction or addition based on the third and the fourth quadrant. So we could do that either way. So negative square root of 3 over 2. And we'll come over here and we'll try to find that negative square root of 3 over 2. And remember, we're dealing with sine, so don't be fooled by this one right here. You might think, oh, it's 210. No, it's not, because we're not looking for cosine. That's cosine. And here's kind of the tricky thing is normally we think about sine as the first one, right? Sine, then cosine. So you might be thinking, oh, that's sine. No, no, no. In the unit circle, this first one is cosine, okay? Because that is the x coordinate, and the x is your cosine. The y, the second one, is your sine. Okay, so we have that one there, and then we have another one right here. So we have the 240-degree angle, and we also have the 300. So there's your 2 answers. The other way that you could do this is you could actually go up here in the unit circle, and that 60 is your reference angle, right? So you could say, okay, I know I'm in the third, and so I do 180 plus 60. So what is 180 plus 60? Well, it's 240. And then you could say, and I know I'm in the fourth, so 360 minus 60, there it is, 300. Okay, so you could do that either way. So 240 and 300 is our correct answer. So 240 and 300 are our 2 answers for that one. All right, so here's our next example. 1.5 plus the sine of x equals 0. Right now, maybe you're thinking, hey, I like these equations. These are easy. This is fun. Good. I'm glad you're getting it. So hopefully you remember your basic algebra, and hopefully you're thinking, man, this is really easy. That might change in the next video, but I'm glad that you're understanding so far. That's awesome. So keep working hard on this, all right? So what do we do first? Well, in basic equations, this is obviously our variable, so we're going to try to get this to the other side. How do we do that? Subtract 1.5 from both sides. That's going to cancel that out. We're going to get sine of x equals negative 1.5. Now, something to think about, and you can use your calculator on this one, but do you remember the range and the domain of sine? the range of sine is from 0 to what? Do you remember? 0 to 1. Okay. So obviously we have a problem out here, right? We have a negative, and sine could be negative too. So you could have 0 to -1. So it goes both ways. So you could potentially have it anywhere within that range, right? From 0, or well, really from -1 to +1. Well, look here, this is outside of that range. In other words, if we go to our calculator right here and we try to put that in. So how do you find, okay, so let's say we want the angle from this, right? So how do you do that? Do you remember? You do sine of -1x equals, whatever, and then we're going to put that in. So if we try to find the angle for this sine, so if we go in here and we do sine, so shift sine, that gives us sine -1 of 1.5. Well, really -1.5. So if we do -1.5, and then we put our parenthesis over that, let's see what it equals. And it says math error. Wrong. Okay, what did we do wrong? What we did wrong is it's outside of the range of sine. Sine can only be between -1 and +1. So our calculator will reject that. So what we get here is the sine of -1.5 equals, or this equation equals, no solution. And that would be the best way to write that. You could also write math error if you wanted to, but no solution is typically what most professors are going to want to see right there. Well, that's all I have for you in this lesson. There's 3 more practice problems, more examples there that I'm going to do in a second lesson on this. There's no way for me to cram all that into one, and they do get more challenging. So don't think, oh, these are easy, so I'm not going to watch the second video. You better watch the second video because you're going to learn some stuff, okay? And we start getting into substitutions. We start getting into, remember those identities that we need to use back of there on the cover on page B. So make sure that you watch that next video because it is going to be important. All right, that's all I have for you. Hope you learned something. If not, scroll it back and watch it again. We'll see you later. Have a good one. Bye-bye.